Hey everybody, welcome to a brief introduction to C++. In the next 20 to 25 minutes, I'll be giving you an overview of the C++ language. We'll discuss some of the features that make it a great language, and we'll go into a bit more detail in its standout features. Then we'll do a code demo where we will be solving one of the exercises on the C++ track, and we'll finish off by listing some of the resources that you can use to learn C++. I'm excited, so let's get started. C++ was developed by Bjarne Stroustrup. The first version was released in 1985. C++ is a strong and statically typed language. It has originally been designed as C with classes, so adding object-oriented features to C, but ever since that first release, C++ has added tons of new features to it that no longer make it just C with classes. It's its own language, and it supports multiple paradigms, for example. You can, of course, do imperative/procedural programming. You can do object-oriented programming, but you can even do a bit of functional programming in C++. And that's one of the core design tenets of C++, that people can decide how they want to work with C++ themselves. C++ has been an official standard since 1989 and is being regularly updated still. Every 3 years or so, a new version of the C++ specification is released, and new features are regularly added to them, such that they make C++ a fairly modern language, even though it has been around for a very long time. C++ is also a highly influential language. It has popularized object-oriented programming, you could say. Other languages have done that too, but C++ was one of the first big object-oriented languages, and thus helped popularize object-oriented programming to the masses. C++ is being used in many different ways. For example, many game engines are written in C++, but also Windows has been written in large parts in C++, but you find databases and browsers and device drivers and tons of different software have been written in C++, and it's basically everywhere. Let's discuss some of the reasons why C++ is a great language. First of all, C++ is continuously evolving. I mentioned before that C++ has a specification that's regularly updated, but these specifications really add cool and modern stuff to the language. Even though C++ has been around since 1985, you get all sorts of modern goodness in C++ that you wouldn't expect from a language that old. And these include things like type inference, ranges, coroutines, and even compile time execution of code. These are all features that are now in C++ in the official standard, so you might not know all of them if you've only done C++ 20 to 30 years ago. So continuously check out what the latest release of C++ gives you, because there might be a lot of goodness in it for you. A second reason why C++ is great is because it's really expressive. You can do a ton of things with very little code. And this is because of the aforementioned modern features that C++ has, but also because of its extensive standard library, which I'll get to in a second. And then third, C++ has advanced memory management features. So for example, in C, you have to manually allocate everything and deallocate everything. So that's somewhat of a chore, but C++ has always had features where it would be a slightly easier way to allocate and deallocate memory. But not only did it have that, it has since added features that do away with the manual memory management altogether. So C++ has a thing that's called resource acquisition is initialization, so RAII, and that's a very fancy name for basically the compiler figuring out when to allocate and deallocate memory for you without you having to do it manually. C++ also has a feature that's called move semantics, which you also might know from Rust. And it means that the compiler can sometimes determine situations in which it is, if you want to use a bit of data, it doesn't have to make a copy, because again, gives certain guarantees that that copy is or isn't mutated. So this prevents unnecessary copies from memory being made, which is great for performance and memory. And then finally, because with all these features, even though you have to don't do much yourself, it's still very deterministic. So many languages offer automatic memory management, via a garbage collector. And a downside of that is that the garbage collector at some point will usually halt your program. It can be concurrent, but it has to do a bit of work to figure out what things need to be deallocated. And you don't have that in C++. C++ doesn't have a garbage collector, but it does have all these benefits where you can still do automatic management, memory management, and just have C++ figure it out for you. And that's excellent for performance. So you don't have any hiccups in your code for the garbage collector, just figuring out what to delete. Let's discuss the standout features of C++. First of all, its performance. C++ is fantastic if you want to write high-performance code. If you ever go online and look up some benchmarks for algorithms or web servers or whatever, you'll often find C++ source code at the top or near the top. In other words, C++ has proven itself to be one of the best performing languages. And that's also a testament for the fact that C++ is used in game engines, which really value performance, and is used on on supercomputers to offer high performance computing. One of the reasons why this is such is that C++ is designed in a way to be very performant. So the C++ commands and statements, etc., map very well to the way in which a CPU runs its instructions. So there is less of an overhead there. But also the base library, the standard library has basically anything that's implemented in it is designed in a way that it allows for high performant code to be run. The second standout feature is the fact that the standard library is huge. So the standard library consists of many different things. You'll have algorithms like sorting and permutations. You'll have data types like complex numbers. You'll have data structures like queues and priority queues and sets and maps. And you'll have utility functions like bit manipulation. It's basically incredible what you have at your disposal if you look at what C++ gives you out of the box. So if you want to build something, make sure to really check out what's already there in the standard library, because chances are it's already being built and it will be highly performant. So always try to use the things that are in the standard library before implementing things yourselves. The third standout feature is C++'s support for generic programming. In C++, you can define a function using a template that takes a type as its parameter. And that type is then executed, the code is executed at compile time. So you can, at compile time, generate the right version of the code for that type. And this is very powerful. So as I said, you could write a function that takes in a type as its parameter and then have it be applicable to basically any type for which it is generating valid code. So this means that, for example, if you have a sorting algorithm, that sorting algorithm could take the thing to sort on as the argument. And then if you're using it to sort integers and to strings, the compiler can then generate at compile time the right code for strings and integers, but only for those. So only for the things that are actually being used. So you don't incur any of the downside of it generating a lot of code for things that it doesn't need. And the fact that you can run this at compile time could also be used for pre-calculating things like expensive calculations. For example, if something is being calculated in 5 seconds, you could have it be calculated at compile time. And then you only incur the cost once when compiling, but not at runtime. You can also do this in a different way, which is via const exp, which is a fairly new C++ feature where you can do compile time execution. That's actually a better way to do it than templates, but you can do it with templates. And templates are Turing complete, so you can compute anything at compile time. So that's a very powerful feature. It is being used in the standard library, and a ton of libraries also use this, for example, to build little DSLs, domain-specific languages, that allow you to write code that is very natural to read, even though it might not be the actual C++ code that gets executed at runtime. That is what the template then can translate to. So you have all the benefits of having this nice bit of DSL in your code, and the messiness is hidden for you via the template. The fourth and last standout feature is the fact that C++ runs everywhere. It is very hard to find a platform that doesn't run C++ code. So if you want to build code that is portable across a wide variety of platforms, C++ is an excellent choice. Let's look at some actual C++ code. We will be solving the reverse string exercise. And this exercise is quite simple. It takes a string and you have to return the reverse of the string. So if you pass in ABC, you get returned CBA. And that's the entirety of the exercise. I will be using the CLine IDE, which is an IDE by JetBrains, which I quite like, but you can do this in any IDE that you like, a VS Code or whatever you prefer. Let's look at what we already have. So this is the test file. You see a lot of test cases, and we need to infer from this test file what we need to implement. So there's a namespace called reverse string, and we need to have a reverse string function that takes in a string and returns a string. So to do that, we first go to the reverse string header file, and in C++, like C, you have header files and implementation files. And header files are the definitions that you want to share with other bits of code. So we want to share that we have a reverse string function, and that function takes a single string input, and the type that we need to use is std : string, and we'll call the value input, close with a semicolon, and that's also the thing that we are returning. Well, we can't use std : string by default. We need to import the string header. So now we have a bit of header file that says that we expose the reverse string function. It takes string and returns a string. So let's go over to our implementation file. So reverse string.cpp, copy this here, and then we'll do this, and then we can implement our logic. The simplest version that we can implement is just to return the input string. Then we can go to our test file and run our tests and see, well, we got 3 tests failed, 2 are passing. The passing ones must be due to empty strings, so that's all fine. But this is obviously not the right implementation because we are not passing all the tests. So we'll do a naive approach first, where we create a variable for the reverse string. So another string, and then we'll do a reverse iteration over the length of the input. So we'll say length is input dot length, and then we'll do for int I equals length minus 1. So we'll do counting from backwards to forth. So we'll do greater or equal than 0, I minus minus. So we will be going from the last index up until the very first. And that's the thing that we will use, because we can then do reversed dot plus equals. So we'll add a character, and we will add the ith most character of the input. So we are allocating a string that will have the reversed string. We will we calculate its length of the input string. Then we use that length to reverse iterate over all the characters in the input, and then add those in the reverse order to reversed. So in the end, we need to return reversed. And that, if we run all the tests, we should get everything passing, and we do. So we now have a first working version of our reverse string, but this is not optimal. To make this more optimal, we need to get rid of this additional allocation. We are allocating a new string, and that's especially bad if we have long inputs, whereas instead we could have been mutating the parameter itself, because this is by default now passed in as a copy. So we can mutate the parameter safely without actually having mutating the original argument that was passed into the function, as this is a copy. So let's get rid of all this. And instead of doing this, what we will do is we have an algorithm where we will start at the leftmost and the rightmost character. We'll swap them, then we'll move inwards, and we'll continue until we've reached the middle. So for that, we need to define 2 variables. We'll call one left, start at 0. We'll call one right, start at input.length minus 1. And then we'll have a while loop. So while left is less than right. So this means that we still have a pair that we can swap. And then within this function, we need to say, hey, we'll have a temporary character. So we'll call this, input left. And then we'll say input left is input right. So now the leftmost character is equal to the rightmost. And then we have to do the reverse. So the rightmost character is equal to what formerly was the leftmost character, which is why we need the temporary value, because otherwise we would have it be the same value. And then we must not forget to increment left and decrement right. And in the end, we just return input. So this is a different algorithm. We're now mutating in place. And this is the key difference from our previous approach, because we're now mutating the already allocated string. So we're no longer allocating a new string, we're mutating, and that's a lot better performance-wise. So let's run this, and we get a failing test because we haven't handled the empty string. And you might be wondering, why is that? Because if the empty string is here, it would be length 0 minus 1. Then it would be minus 1 is less than 0, so that would just mean it wouldn't run the while loop. Well, unfortunately, the problem is in the size t type, and the size t type is defined as an unsigned value, which means that its lowest value is 0. So 0 minus 1 for an unsigned value will underflow, so it will be a very large value. So we have to consider the fact that the input can be empty. So we can do if input.empty, and then we'll just return input. So run this again, and now we have a passing test. So this is now a more optimal version. We did have to add this little bit, but this is far more memory efficient and it will perform better, especially on large strings. One tweak that we can make is this manual swapping of the left and the right inputs. There's actually a built-in function for that. That's called std swap, and we'll pass in the left, we'll pass in the right, get rid of all this code, and then we'll rerun the code. And this is still all passing. So you can see that this is a typical example of where C++ already provides you with things that you can use to optimize things. So swapping things is quite common, for example, in sorting algorithms, etc. And there's a built-in function to do that. So we have used this to our benefit. There is, however, a more optimal way to do this, and it's very, very short. As a matter of fact, I can actually get rid of everything, and I can do include algorithm. So this is a special namespace that contains a lot of algorithmic functions, and one of them is std : reverse. And the reverse function takes in a bidirectional iterator, first and the last. So this means that you should start at one end, that's the first argument, and the other end is the second argument. And a string has a property begin, which is an iterator, and a property that's called end. And then we can simply return this. We can simply return the input string after this, and it should all still work. So let's run this, and we still have our passing test. So you can see that we could have, we started out with a fairly unoptimal version, then we sort of manually optimized things a bit, but we now saw that the standard library actually has something for us, and it will be very, very optimal. It will be working with iterators, and iterators are a very nice and optimal way of iterating over a value without allocating too much. So this standard reverse version is very readable, but it's still highly performant. So this is a great example of why C++ can be a very expressive language with a lot of built-in functionality that you can use while still being very, very high performant. If you want to learn some C++, here are some resources that you can use. First of all, you can use the C++ track on Exercism. There are almost 60 exercises with a wide variety of topics and difficulties, and they really allow you to try out the different ways in which you can solve things in C++. So they're a great way to take a single problem and then approach it in different ways and explore the standard library. See if there are things that are already implemented for you that you can use. So highly recommend you trying out the C++ track on Exercism. A second resource that you can use is learncpp.com. It is one of the best ways in which you can get introduced to the language. So they have a lot of things ranging from the basics to far more advanced stuff. So it is a great resource if you want to get up to speed with the C++ language. If you want to know what's in the standard library, and as I mentioned, that is huge, cppreference.com is a great website to use. There are a ton of different things here. There are everything from containers like lists and sets and to classes, statements. There is just a ton of things that you can use. So I highly recommend you trying out visiting this website to see what the standard library has in it for you. Then there is this isocpp.github.io website /cppcore guidelines /cppcore guidelines. It's quite a bit of a mouthful, but this is basically a document that contains guidance on how to write proper modern C++. So this is really recommended if you want to know the idiomatic way in which you write C++ code, and there's a lot of guidance here on concurrency and resource management and just a lot of goodness here that you can use. Then there is a YouTube channel, CPPCon, and they have a lot of useful videos that explore a wide variety of topics, and it's highly recommended. And if you are one of the person that prefer learning via videos, I highly recommend this resource. If though you prefer to learn from a book, the Tour of C++ is an excellent resource. It has been written by this author of C++, Bjarne Stroustrup. So you can be sure that the author knows what he's talking about. If you'd like another book, Effective Modern C++ is a great resource that you can use to learn about modern C++. And as I mentioned, C++ is a very evolving language. So with this book, you get lots of the more modern goodness in C++ taught to you. With that, we've reached the end of this video. I hope this has been useful to you and that you're now excited to dig a bit deeper into C++, and that we see you soon at the C++ track on Exercism. Thank you for watching. See you next time. Bye.